TF coils are gigantic D-shaped superconducting magnets used to confine the plasma. Today, all the 19 TF coils have been manufactured, 9 in Japan and 10 in Europe.
Unprecedented niobium-13 strand and conductor production volumes had to be mastered, and therefore the TF conductor production has been shared among 6 DAs and many suppliers distributed all over the world. In total, 87 kilometers of TF conductor and more than 400 tons of superconducting niobium-13 strand have been produced for the ITER TF coils. ITER TF conductor is a so-called cable and conduit conductor, and the production consists of 3 main steps. The first one is the strand fabrication, where niobium-13 rods are stacked into a copper matrix, extruded and cold drawn to reach the final diameter. The next step is the cabling, where more than 1000 superconducting and copper strands are twisted together. The last step is to insert the cable into the stainless steel conduit and compact the conductor to its final dimensions.
China was responsible for the production of 11 conductor unit lines, corresponding to more than 1 complete TF coil.
Europe, the Fusion for Energy, were responsible for the production of 27 conductor unit lengths, corresponding to almost 4 complete TF coils.
JA was responsible for 33 conductor unit lengths, corresponding to almost 5 TF coils.
Korea was responsible for the production of 27 conductor unit lengths, corresponding to almost 4 complete TF coils.
Russia was responsible for production of 26 conductor unit lengths, corresponding to almost 4 complete TF coils.
The US ITER organization was responsible for the production of 9 conductor unit lengths, corresponding to more than 1 complete TF coil.
10 winding packs are produced in La Spezia, Italy, and 9 in Kobe and Yokohama, Japan.
Then I was very happy when they decided to go ahead with ITER, and they called me and say, okay, would you like to come and be responsible for the TF coil? It was like a dream coming true. See, that is not a work for emotional weak people, because you need to be very strong and confident, because otherwise you will never do anything. You will just be so scared. So we are today in ASG facilities. That is the place where a part of the TF coil will be built. The TF coil is composed by 7 double pancake modules. They are called double pancake for the way they are stuck to each other. Behind me you can see the winding tooling. That's where all the operations start. This is the tooling which is responsible to shape the conductor on the right trajectory. You can see the big spool containing 750 meters of conductor. It is assembled on the unspooling device, which is essentially responsible for unwinding the conductor. Then we have the straightening unit, which is straightening the conductor, followed by a cleaning station and a sandblasting station, which create the right level of roughness on the surface of the conductor. And finally, you have the most important part of the equipment, which is the bending tooling, which is responsible for bending the conductor on the right trajectory with the required level of precision and accuracy.
The radial plates are gigantic D-shaped stainless steel plates with spiral groove machines on both sides. They are made of several segments machined and welded together. In Europe, some of them are tungsten inner gas welded, while others electron beam welded. In Japan, a combination of laser and tungsten inner gas is used. After welding, the final machine is carried out. The length of the groove is up to 750 meters, and an accuracy is required for the length groove of tenths of parts per million.
My name is Jordi Cornellà. I'm a technical officer for the toroidal field coils. This machine is the insulation tool. It grabs the electrical insulation around the superconductor. Once we have placed the superconductor inside the radio plate, we need to start wrapping the electrical insulation around it. It consists of several layers of glass Kapton tape plus the quench detection tape. The machine works with 4 trolleys that lift the conductor to a certain height. Then there are another 4 trolleys that grabs the electrical insulation around it, and then another 4 trolleys puts down the conductor inside the grooves of the radio plate.
Double pancake is composed of an insulated superconducting cable, which is wounded into 2-layer D-shaped spiral, inserted into stainless steel structure and impregnated with epoxy resin. To produce a winding pack, 7 double pancakes are stacked and electrically insulated.
Once completed, the winding pack are inserted into the coil cases, and then they are welded together. As a final stage, the TF coil is machined in order to get to the final geometrical tolerances. The insertion in Europe is done in Italy, in Marghera, close to Venice, and in Japan, in Kobe and in Kein.
The subassembly composed of several segments. The segments are fabricated with many machining and welding. The fabricated segments are welded in one big 16-meter long subassembly. Because the thickness is quite large, like 20 centimeters, there is a big fight to welding deformation.
The TF coils are loaded in Japan and Italy, in the port of Yokohama and Kobe in Japan, and in the port of Porto Marghera in Italy. They are transported on heavy lift vessels equipped with cranes, and the ocean transportation from Japan is about 55 days and 4 days from Porto Marghera in Italy. In France, the TF coils are unloaded in Fos-sur-Mer, where they are directly delivered on hydraulic trailers to be then transported over the itinerary up to the ITER site.
Obviously, for the assembly, one of our main targets is to pursue the effort that has been implemented at the supplier premises with the DAs in order to manufacture the coils, and with the target to achieve the same level of requirements and level of performance with the installation on site. We are really happy that we can proceed with the assembly now.